everyone, welcome to Mathworld. This is Cambridge International AS and A Level Further Mathematics, Paper 2 for October-November 2022. The code is 9231/22. Right, in this video, I'm going to discuss questions 7 and 8. So this is the question 7a. It is given that lambda is an eigenvalue of the non-singular square matrix A with corresponding eigenvector E. Show that inverse of lambda is an eigenvalue of A inverse for which E is a corresponding eigenvector. Okay, so we know that AE equals to lambda E. Given lambda is the eigenvalue and the E is eigenvector of matrix A. So in order to get A inverse, we will put A inverse both sides. Okay, so A inverse A is I. So left side, you'll be getting IE. And since the right hand side, A inverse is a matrix, lambda is a constant, and E is a vector. So we can factorize the lambda, and you will be getting lambda bracket A inverse E. Now, IE is E. Okay, so the lambda on the right hand side can be moved to the left hand side because 1 over lambda. And then the right hand side will be A inverse E. So if I rearrange, I will be getting A inverse E is lambda inverse E. So which is a similar form as the original equation. AE is lambda E. Okay, so with this, right, we have proven that lambda inverse is an eigenvalue of A inverse. And E is the corresponding eigenvector. Okay, so that's all for 7a. Alright, now, given matrix A is a 3 times 3 matrix that consists of first row 2, 0, 3, second row 15, minus 4, 3, and the third row 3, 0, 2. Now, given that minus 1 is an eigenvalue, means that this is lambda, find a corresponding eigenvector. So we will start with AE equals to lambda E. So now my A consists of 2, 0, 3, 15 minus 4, 3, 3, 0, 2. And then my E, I will let it be X, Y, Z. Lambda will be minus 1. Okay, so now form 3 equations. So to get the equations, first row multiply by column. So when you multiply, basically we will be getting 2x, this is 2, plus 3z is minus x, then 5x minus 4y plus 3z is minus y, and then 3x plus 2z equals to minus z. Now, for the first equation, I may get 2x or 3x, move this minus x to the left hand side. So I'm getting 3x equals to minus 3z, which means my x is minus z. Now, for the third equation, I will move the 2z to the right side. Okay, so, and again, I'm getting the same equation. 3x equals to minus 3z, therefore my x is minus z. So, since you are getting 2 equations with 3 variables, because the first and third are the same, okay, that means you'll be getting the infinite solution. So, I will let my z equals to t. Therefore, my x will be minus t. And to get the y, I will move this minus 4y to the right side. So, I will be getting 3y equals to 5x minus 4 plus 3z. So my z is t. So from here, my y will be here, right hand side. Okay, let me check. Now, there is a mistake here, is 15, right? So just change the 5 to 15. So for the right hand side, I will be getting minus 15t plus 3t, which means you are getting minus 12t. Minus 12t divided by 3 will be minus 4t. Once you have found all this, then just rewrite. So your x, y, z, now your x is minus t, so I may factorize minus 1, minus t, then I will write 1. Then my y is minus 4t, so once I factorize minus t, I'll be getting 4. And then for the z is t, so once I factorize minus t, I'll be getting minus 1. So which means my eigenvector will be 1, 4, minus 1. Okay, so this is how we get the solution. Now for C, it is also given that 0, 1, 0 and 1, 2, 1 are eigenvectors of A. Find the corresponding eigenvalues. So now given two eigenvectors. So now use the method AE is lambda E. Okay, use this formula. So you multiply A, matrix A, to the given eigenvector. So I will rewrite my matrix A. Okay, this is my matrix A, multiplied by the given eigenvector, which is my AE. Then I should get lambda E as well. So now I will just do expansion, row times column, okay, row times column. So 2 times 0 is 0. So probably you can just do step by step. Plus 0 times 1 plus 3 times 0. Okay, then the next is 15 times 0. Second row times first column. So second row times first column. So then plus negative 4 times 1 plus 3 times 0. Then lastly, third row times first column. So I will get 3 times 0 plus 0 times 1 plus 2 times 0. 2 times 0 here. Okay, so when you simplify, the first one is 0, the second is minus 4, and the third is 0. So now, don't forget that we have to express in AE is lambda E. So I should get the same eigenvector, which is 0, 1, 0, from 0, minus 4, 0. So which means I will be getting 0, 1, 0 by factorizing minus 4. Okay, probably I will just write here. So once you have obtained AE is lambda E, right? So obviously this is our lambda. So now the lambda equals to minus 4. When eigenvector equals to 0, 1, 0. Now same for the next eigenvector. So just repeat the steps. This is a matrix A. Multiply with 1, 2, 1. Okay, so now do expansion, row times column. So row 1 times column. So I will get 2 times 1 plus 0 times 2 plus 3 times 1. Alright, then followed by second row times first column of the next matrix. So I will get 15 times 1 plus minus 4 times 2 plus 3 times 1. Lastly, last row times first column. So 3 times 1 plus 0 times 2 plus 2 times 1. So just multiply. So now at last you will get 5, 10 and 5. Okay, remember we must get 1 to 1. So 1 to 1, 5, 10, 5 can be expressed as 1 to 1 once we have factorized 5. So obviously this 5 is our next eigenvalue. So I will write lambda equals to 5 when E is 1 to 1. Okay, so this is how we solve 7C. Right, so now let's move on to D. Hence means use the previous answers, find a matrix P and D such that A inverse is PD P inverse. Now, basically, okay, the original should be D equals to P inverse AB. This is the original equation when you diagonalize the matrix. So from here, if you need to get the A as a subject, alright, so we need to multiply the P and the P inverse. One front, one back. Then here P will be P inverse, AP, then P inverse. So that the P inverse is I, then A P inverse is another I. Okay, on the right side. So when you compare, okay, or before we compare, so on the right side, I will get IAI, which is the which is the A. So I will get A equals to PD P inverse. Okay, but then now if you compare with this, the given equation, so let's say here, I will let this be, so compare with A inverse equals to PD P inverse. So let me write my A, label my A as A1, okay, my D as D1, so that you can see the difference. So if you compare first and second, all right, so from here we know that my A1 is the A inverse, which means my D1 will be the, or I will say that if here left hand side becomes A, okay, A inverse, right? Here becomes A inverse, my D1 is basically becomes inverse, okay, which means my D in the equation 2 will be the inverse of the D, or the original. So, which means my D equals to the D1 inverse. Okay, so then the P has no change. So therefore, from here, I will say my P, right, or probably I will write down my D first. The D in the equation will be the diagonal matrix that consists of the eigenvalues. Okay, but provided it will be the inverse of the original eigenvalues. So now, by referring to the previous, first of all, eigenvalue number 1 is -1. So now, your inverse of -1 means that it will be 1 over -1. So I will get -1 as well. Then, okay, so when lambda equals to -1, my eigenvector will be 1, 4, -1. So I have to rewrite. I have to write here 1, 4, -1, so that the P, the column of the P, is basically the eigenvector corresponds to the first eigenvalue. So now, my second eigenvalue will be -4. Okay, so now since we are taking the inverse of -4, it becomes -1 over 4, and the eigenvector is 0, 1, 0. So here, -1 over 4, 0, 1, 0. Okay, and lastly, my third lambda is 5. So when I take the inverse of 5, it will be 1 over 5, and the eigenvector is 1, 2, 1. So 1 over 5. Here, 1, 2, 1. So this is how we get the D and P matrices. Okay, so now let's move on to E. Use the characteristic equation of A to show that A inverse is PA squared plus QI, where the P and Q are rational numbers to be determined. So the I is the identity matrix, right? So now, from the A, we know that it has 3 eigenvalues, right? So we will have -1, minus 4, yeah, and 5. These are the three eigenvalues. Therefore, the characteristic equation of A it will be lambda minus first eigenvector, eigenvalue, then lambda minus second eigenvalue, and lambda minus third eigenvalue, and let it be 0. So from here, you just do solve the, just do the expansion. So lambda plus 1 times lambda plus 4 times lambda minus 5 equals to 0. So from here, you'll be getting lambda plus 1 to the expansion. It would be a quadratic. So lambda squared minus lambda minus 20 equals to 0. And do expansion again. Lambda cubed minus lambda squared minus 20 lambda plus lambda squared minus lambda minus 20 equals to 0. Now simplify this, you'll be getting a cubic equation in terms of lambda. Right? So from here, since we get the lambda values, this is the characteristic equation of A. So you can simply change this to matrix, right? So here becomes matrix A cubed minus 21 matrix A minus 20. Now, if you just write 20, it is wrong because A is a matrix. So this must be an equation of matrix. Therefore, times I. Okay, I is the identity matrix. Now, we need to get A inverse from the question. But now we are getting A cubed. Okay, the A inverse is not there. So what to do? We have to get the I as a subject first, the 20I as a subject. So 20I equals to A cubed minus 21A. And after that, to get the inverse, we will just take inverse both sides. So A inverse times 20I equals to A inverse times A cubed minus 21A. Alright, so 20I, the I and A inverse will be the A inverse itself. So 20 A inverse equals to, here we do expansion. So A inverse times A cubed, it will be A squared. A inverse times A, it will be I. Okay, and here we get the I. Now, we need to get A inverse if you refer to the question. But here we have 20. So move down the 20 and you'll be getting the answer. It will be 1 over 20 A squared minus 21 over 20 I. Means that your P is 1 over 20 and the Q is negative 21 over 20. So this is how we solve the part E of this question. Okay? Right? So let's move on to the last question of this paper, which is question 8. Now, it is given that y equals to cos u, where u more than 0, and square root of cos square u minus 1 times d square u over dx squared plus du dx, then plus cos u times square of du dx minus 2 cos u equals to 4e minus x. This is the given equation. Now, 8, show that d square y over dx squared plus dy dx minus 2y equals to 4e minus x. So instead of y in terms of u, now you need to get dy over dx, or the second order equation in terms of, second order differential equation in terms of y and x. Alright, so now we start with y equals to cos u. So where y in terms of u, we need to get dy over dx, means that we need to apply the chain rule to get the dy over dx. So which means dy over dx, it will be dy over du times du over dx. Alright, so differentiate cos u, it will be sin u. Then rewrite the du over dx. Okay, so now to get the d squared y over dx squared, again we need to apply the chain rule. Okay, so now d squared y, so I'll show it side by side. D squared y over dx squared, it will be d over dx dy over dx. Okay, so now here will be d over dx sine u du over dx. So now, when you need to differentiate sine u du dx with respect to x, then we have to apply the product rule. Okay, so keep the sine u, differentiate du dx with respect to x. Since this is the same variable, you will get d square u over dx squared plus keep the du over dx to differentiate the sign. Okay, but you need to differentiate the sign here, right? Sine u with respect to x. Again, use back the concept from dy dx over in the previous parts, which means we are going to apply the chain rule as well. So differentiate sine u cos u, then du over dx. Right? So now we can simplify. D square y over dx squared is basically sine u, d square u over dx squared plus cos u, the square of du over dx. Okay, so once you have obtained these two expressions, so now we substitute into the left hand side of your second order differential equations and change and make sure we can solve. We can show that it is 4e minus x. So now d square y over dx squared plus dy over dx minus 2y equals to, okay, so replace sine u d square u over dx squared plus cos u du over dx squared. That will be the expression for second derivative, which is the d square y over dx squared. Now, dy dx will be sine u du dx. Okay, minus 2y. So our y is the cos u. Okay, so now, given that 4e minus x, right, equals to all these expressions in terms of u. So it means that now we are trying to get all these terms. Then you can easily prove the second order differential equation. Okay, so from here, we know that we should keep the first and second derivative of u with respect to x. Then the rest will in terms of u. Right, so now, so the first one I have sine u. Okay, and then I have d square u over dx squared. So now from here, you will notice that the sine u can be factorized because what you need to prove now here is the one with the cos squared u minus 1 square root of cos squared u minus 1. This is basically the sine u. Okay, then cos u, after that, the 2 cos u without the derivative term. So therefore, I need to group these two terms, which is the sine u. So I will group them first. Then I will write d square u over dx squared plus du over dx. Okay, first and third term already simplified. Then we write the second term, which is a cos u square of du dx squared, square of du dx, then followed by minus 2 cos u. So you know that sine u, okay, or the identity cos square u minus sine square u is 1. This is the identity. Okay, so okay, I will just write using different color. So cos square u minus sine square u is 1. Now I'm getting sine u here. So you moved. So it means that sine square u equals to cos square u minus 1. Okay, so means sine u is square root cos square u minus 1. So this is how we prove. So with this, then I will change sin u to cos square u minus 1, then rewrite these two terms. And the rest just rewrite. Okay, therefore, it is same as the given expression. Then I will easily change to 4e minus x. Right? So this is how we solve the A. Okay? So now, last part. Find u in terms of x. Given that when x goes to 0, u is ln 3, du dx is 3. So when you need to solve for the u, which means you need to solve the second order differential equation. So I will start with the second order differential equation, d squared y over dx squared plus dy dx minus 2y equals to 4e minus x. Right, because we know that your y equals to cos u. If you need to find u, that is the arc cos y. So that's why we need to solve for the y at this moment. So now let the right hand side be 0. Okay, then you will get the characteristic equation m squared plus m minus 2 equals to 0. You'll be getting m equals to 1 and minus 2. Therefore, your general solution is aex plus be minus 2x. Alright, now when we look at the right hand side, which is 4e minus x, I will let my trial solution, okay, so let trial solution be y equals to pe minus x. So then make sure you compare with the general solution and there is no repetition in these two expressions. So now then we can just differentiate 2 times. So dy dx will be minus pe minus x, and the d squared y over dx squared, it will be pe minus x. Let all this be second equation and the original be the first equation. Okay, then now substitute second into first to get the p value. So I will get pe minus x plus negative pe minus x, which is our dy dx, minus 2 the y, then equals to 4e minus x. So the first two terms will be cancelled off, then I will get minus 2p equals to 4 when you compare the coefficient for the e minus x. Hence, my p will be negative 2. Once you get your p equals to negative 2, you can just write particular solution. You can just write this is basically the CF, this is the PI, particular integral. Then your y will be minus 2e minus x. Hence, the general solution. Your y will be ae x plus be minus 2x plus negative 2e negative x. So plus and minus, it becomes minus. Alright. Now, since you need to find the u in terms of x and our y is cos u. So now I'm going to change my y to cos u. Then aex plus be minus 2x minus 2e minus x. Okay, so now you are given the values. When x is 0, your u is ln 3 and du dx is 3. So write down all these 3 values. So when x is 0, your u is ln 3. So now replace. So I will get cos ln 3 equals to ae0. e0 is 1. So a plus b minus 2 because e0 is 1. So now cos, okay, cos ln 3. So for your information, cos x is half of ex plus e minus x. This is a definition for cosh. So I'm going to change to half, okay, e ln x, because my x has been changed to ln, e ln 3, because my x has been changed to ln 3. So e ln 3 plus e negative ln 3 equals to a plus b minus 2. Alright, so e ln 3 is basically 3, but e negative ln 3 is 1 over 3. Okay, so when you simplify, a plus b equals to 11 over 3. This is my third equation. Alright, so now, just now you were given three values, x, u, and du dx. Therefore, I need to differentiate first. Differentiate the u with respect to x before I apply this value. Right? So now, you refer to the cos u. So when you differentiate cos u, it will be sin u du over dx. Okay? Then the right hand side, aex remains. So aex. Then the be minus 2x, when you differentiate, it becomes negative 2be minus 2x. And the minus 2e minus x becomes plus 2e minus x. So now again, replace the x value by 0. And then the du dx by the given value. Let's check. The du dx is 3. Okay, so here is 3. Now, sin u. So sin u. Okay, x is 0. Your u is ln 3. So now sin ln 3. Du dx is 3. So another 3 here. Right? That equals to x is 0. So a minus 2b plus 2 on the right hand side. Okay, so now again, use back the definition for sin. So we know that sin x is half of ex minus e minus x. This is the definition for sin. So what to do here is 3 sin ln 3. So change the x to ln 3. I will get half e ln 3 minus e negative ln 3. That equals to a minus 2b plus 2. Okay, so here you will be getting 3 over 2. Again, e ln 3 is 3. Negative e ln 3. Okay, negative e negative ln 3. The e negative ln 3 is basically 1 over 3. So when you rearrange or simplify, it will be a minus 2b equals to 2. This is my fourth equation. So solve third and fourth equations to get the a and b values. Right? So now I may use the third minus fourth. So the a will be eliminated. Then b minus 2b, it will be 3b. Then 11 over 3 minus 2, you'll be getting 5 over 3. So at last, your b will be 5 over 9. Okay, once you get a b, then you substitute into the third equation or fourth equation to get the a. So I will substitute the b value into the fourth equation. So now my a equals to 2 plus 2b. So which is 28 over 9. Once I get my a and b, okay, so now I will rewrite my cos u. So my cos u will be aex. So I will write cos u equals to a is 28 over 9, aex. Okay, then be minus 2x. So the b is 5 over 9. So plus 5 over 9, e minus 2x. And then minus 2e minus x. So here, minus 2e minus x. So since the question asks for u, Okay, when you look at the question carefully, find u in terms of x. So therefore, I will just move the cos to the right side, becomes inverse cos. Okay, so this is the solution of question 8b. Right? So that's all for the working of this video. So if you like my video, don't forget to subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.